in this section, we'll be looking at compound inequalities. So these are like two normal inequalities that have been put together. And so there are two types of inequalities we're going to look at. They are inequalities that are joined by an and or an or. So or solutions are the solutions for either inequality. So either inequality can be true. But for and solutions, both of the inequalities have to be true. So we're looking for where the two solutions overlap in this case. So these first few are just graphing. So for number 1, and we've done this before, so we're just going to review. I'm going to put 3 here and 7 here. Make sure those are in the order they would be on the number line. So x is less than 3. That's going to be a open circle shade to the left. And x is greater than or equal to 7. That's closed circle shade to the right. And this is a or problem, so our answer is wherever either of the two are shaded. So your answers are all the numbers here below 3 and all the numbers above 7, including 7. Example 2 is an and problem, so this is going to be a little bit different. So we have -2 and 5, and we're going to graph these together. So we have x is less than or equal to 5, so we're going to use a closed circle on 5 and shade to the left. Then we are going to graph x is greater than or equal to -2, so we're going to have a closed circle on -2 and we're going to shade to the right. With the and problem, your answer is only the parts of the graph that overlap. So I'm going to make myself a separate graph here to show the final answer a little bit cleaner. So on this graph here, these two overlap from -2 to 5. So we would use closed circles in both cases because both of these are less than or equal to or greater than or equal to. And we're going to shade in between. So this would be my final answer. Most of the time, and problems are going to be the answer between two numbers, whereas or problems will go away from each other most of the time, but not necessarily all of the time. Okay. Example 3, we've got -2 less than or equal to x less than 0. And so for this problem, we're looking at all the numbers where -2 is less than the number. So -2 has to be below the numbers we're talking about. And then x has to be less than 0. So the numbers are less than 0. So this ends up being all the numbers between -2 and 0. So we're going to have a closed circle here, an open circle here, and we're going to shade in between. And our last one is or. We've got 1 and 5. So, and if we graph these, we've got x is greater than 1. So we use the open circle and shade above. We have x is less than 5, so we'll have an open circle and we'll shade to the left. Now this is an or problem. So if this was an and problem, we just shade between 1 and 5. But this is an or problem. So for this problem, our answer is the whole entire number line, because every number that exists is either greater than 1 or less than 5. So this, because the whole number line is shaded and this is an or problem, this ends up being all real numbers. If we look at example 5, this one here is a little bit weird. So we're looking for all the numbers where 8 is less than x. So 8 has to be below the numbers, so that would be up here. But x is less than 2, so that would be all the numbers over here. One thing we can do for this is anytime that the inequality is written all together like this, it's a and inequality. So we could break it up into to like this. So that is 8 is less than x, which I also could write as x is greater than 8. So that would be this part. And I would also break it up into x is less than 2. So less than 2, like this. So whenever I do that, remember this is a AND problem, and when we have an AND problem, we're looking for where the two graphs or two inequalities overlap. These do not overlap at all, so this would be no solution. And the graph would just be, if you had to graph it, which you can't really graph this, it would just be an empty number line because none of those are solutions. Okay. Our last one here, we've got -1 and 2. Whenever we graph x is greater than 2, we'll have a closed circle in this way. We have x is less than or equal to -1, so we would have a closed circle and shade to the left. This is a OR problem, so it's perfectly okay that these don't overlap. This is your answer. Okay. So now let's look at some problems where we actually have to do some solving. So for example, 7, if it's an OR problem, just solve the two separately. So we're going to subtract 5, x is less than -7. Over here for this problem, we're going to need to subtract 2 from both sides. So -3x is less than -9. We have to get the x by itself, so we're going to divide by -3. And so x is greater than +3. Notice here that I flipped the sign because I divided by -3, so I had to change that less than sign to a greater than sign. So to graph our answer, I want you to graph all of your answers here. We're going to have 3 and 7. Oops, sorry, we need to do that again because it's not 7, it's -7. And so on the number line, -7 is below +3. That makes a big difference on how you graph it, so make sure that you have those in order whenever you draw them on your number line. So we'll have open circle, shade to the left for -7. We'll have an open circle, shade to the right for number 3. And so this is a OR problem. Those two don't overlap, but that's perfectly fine because it's an OR problem, so this is our answer. For number 8, we have an AND problem. So we're going to solve both of these separately, but we're going to look for where they overlap in this case. So if we solve the first inequality, we're going to add 4 to both sides. So x is greater than 2. And over here, if we're solving this one, we're going to add 4 to both sides. So we get 14 is greater than 2x. We're going to divide by 2. So I get 7 is greater than x. And then I like to write this with the x first, and if I'm going to do that, I've got to flip the sign because the alligator is eating the 7 here. So the alligator has to eat the 7 whenever you turn this around. So we're going to graph this. We've got 2, we've got 7. At 2, we have an open circle, and we're going to shade to the right. At 7, we have an open circle, and we're going to shade to the left. This is an AND problem, so we're only looking for where the two overlap. So our final answer for this, I'm going to draw a clean copy of it here. We have open circles on 2 and 7, and we shade in between because that's where our shading overlaps for this problem. Now, I do want you to do this for these final answers. I could write my answer as x is greater than 2 and x is less than 7. However, typically you're going to see your answer written a different way. You're going to see it written like this. 2 is less than x less than 7. And so if you'll notice, this is still going to be true. Always write your lowest number first, less than x, less than, and then highest number last. If you have closed circles here, you would use the less than or equal to corresponding to each circle, but you're always going to use a less than sign whenever you write this way. Okay, for this one, we're going to do the same thing that we just did. So we are going to break this up into two inequalities. We'll have 3 is less than or equal to 2x minus 5 divided by 3. We'll also have other inequality where we have 2x minus 5 divided by 3 is less than or equal to 9. I'll put an and in between these. So we will solve each one of these. So to solve this, we would first have to multiply by 3, which would give us 9 is less than or equal to 2x minus 5. We will add 5 to both sides, so we get 14 is less than or equal to 2x, and then we'll divide by 2. So 7 is less than or equal to x, or I don't really like to graph it like that, so x is greater than or equal to 7. Over here for this problem, the steps are the same. Multiply both sides by 3. So we get 2x minus 5 is less than or equal to 27. We're going to add 5, which is going to give us 2x is less than or equal to 32. And we'll divide by 2. So x is less than or equal to 16. So if we graph this on the number line, we've got 7 and 16. So 7, we've got greater than or equal to, so we'll use a colored in circle. We're going to shade to the right. For 16, we've got greater than or equal to, so we color that one in. We're going to shade to the left. The overlap is here between, so we could show this as our answer. We also want to write our answer combined here, so we're going to do lowest number, which is 7, less than or equal to. Always use a less than here, but use the less than or equal to because it's colored in. X, less than or equal to. Again, we use less than or equal to because at 16, that's a colored in circle. And then 16. So this is our answer here, and this is our answer here, and this is our graph. Right. For our last one, we've got an OR problem. So we're going to solve each one of these separately. For the first one, we'll add 5 and add 5. So we get 2x is less than 16. And then we'll divide by 2. Divide by 2. So x is less than 8. And over here for this problem, we're going to subtract 2 from both sides. So we get 6 is greater than negative x. This negative x right here, this is like having 6 is greater than negative 1 times x. So we're going to have to divide both sides by negative 1. 6 divided by negative 1 gives you negative 6. And then we divided by negative 1, so we've got to flip this inequality sign. Here it's a greater than, we're going to make it a less than x. And I like to turn this around, x is greater than negative 6. So if we graph this, we've got negative 6. We also have 8. And so if we graph 8, we've got open circle, shade to the left. If we graph at negative 6, we've got open circle, shade to the right. Remember, this was an OR problem, and since this is an OR problem and these two graphs overlap, that means all numbers are possible answers. So we would say all real numbers. In fact, you might want to write down if an OR graph overlaps, the answer